Yeah, so RS for racing. So just very quickly, me, big data scientist at Vodacom, founder of HouseFac. So what is HouseFac? It's a makerspace, longest running makerspace in South Africa. Started using R in 2002. So what does that mean? It means some sort of gray, and I know I'll apply. But that's okay, so this project was, so this is stuff I did in my part-time at HouseFac. So it's basically inspired by this project called Donkey, which is Will Roscoe. And you can see there's a 3D printed frame to this. There's an RC car. The code is there, some really good code, some Docker images to run this thing on, etc. Okay, so what we didn't like about the Donkey project is that you need to use your smartphone to control the RC car. So if you ever raced an RC car, it's quite difficult to do that with a smartphone. You needed to have Wi-Fi, so sometimes you want to race outside and there isn't Wi-Fi. So we removed all of those things and we added the RC back into RC car. And we released this as open source, so that's the link. Okay, so very simple, how does this autonomous car work? So basically what you do is step one, you record some video and the RC input. So as you race the car around the track, you sort of record what it does. Step two, you train this ConvNet, which is basically this mapping between the photo and then the angle and the throttle. So a very simple idea. And then if you want to race, you sort of play this thing back and you put it on the track and then race around the track. Okay, it's cool. All right, so step one, so this is what the car sees. You can see it's sort of trying to race there, and sometimes you go to the left and to the right and you miss it out. And then on the car itself, there's a little Arduino. The Arduino then actually records, like how you race, how you translate it. Okay, so step two, very simple. What you want to do is, so in R, there's this package called Keras. And basically what it does, let me zoom in some more. You can, maybe not that much. Anyway, so then what you do is you can define your ConvNet. So this one has got 5 layers. Then it flattens it out, and then it's got some densely connected layers there and some predictions at the end of the angle of the throttle. Okay? Quite simple. Right. Cool. So then, okay, so that's the theory. So the first try, so I put this on the track, I race around the track, and you can see, so these loss functions don't look great, the accuracy doesn't look great, and so I wanted to say, okay, so fine, there's the third step, or the fourth step here is like debug, what's going on. So this is a mapping now between the actual angle, now this is what I was like, the input I was getting, and this is what was predicted. And when I put this thing on the track and I literally put it down, this thing just raced and I had to like run behind it to go and fetch it. So it was like really like autonomous. Okay, so what's the reason for this? So this is my inputs here. You can see the little photos there. So this is what the car saw in my inputs. You can see sometimes the track goes to the right and I just steer to the left. So it was just like really bad driving. Okay, so we practiced some more, and after some more practicing, we're starting to get like a good relationship between what the input and the output was. But I wanted to go deeper into this thing to really understand like what has it learned. Okay, so this is what the ConvNet sort of looks like. It's got these 5 convolutional layers, and then it flattens it out. And so it's that layer of flattening out, that's where the features are sitting. And really wanting to understand what the features are. So this is what the thing is. So what I could do is I extracted that layer, and then I'm doing a PCA, principal component analysis on that. And you can see there's the angle. So what it sort of does is where the right-hand turn sort of ends up in one place and all the left-hand turns in one, and the middle is a little bit confusing. I wanted to get a little bit more, a better picture of what's going on here. So first thing I did is just sort of, a bit lower resolution. And then what I did is for each of these, what I would do is I would plot the photo, on that, and the arrow to sort of show what, what was going on. And you can see, so like I said, on the left-hand side, you get the, left-hand side, you get the right turns. On the right-hand side, the left turns. And then, like in the middle here, it's got all the squiggly lines and so on. And I guess this is the final step here is just to prove to you that this is actually working. So there's my little car. It's racing around the track. And you'll see that when I say racing around the track, it's like it's slowly like crawling around the track. And like on the table there, you'll see there's the remote control, so you can see this car is completely doing it. You also saw what he did there. It's like completely missed the track, but it was able to sort of correct for that. So that was pretty cool. And then the last thing here, so this presentation, there's an R notebook. The PC board design for the Arduino and the code is all at this link. So if you want to build something like this yourself, please feel free, fork it, pull requests are welcome. So that's all. Thanks.